is 15 terawatt and expected to double by 2050. That's why we're heading to renewable energy sources, mainly the solar ones. But the solar cells are not sufficient. So we will introduce space solar power as a solution to our energy crisis. We will cover the efficiency, the cost, the safety and maintenance, and the conclusion. The highest efficiency of the solar cell is 44.7%, which is not efficient enough to meet the OLED needs. But in the outer space, where the sun rays are not reflected nor scattered by the atmosphere, and the sun radiance is 144% higher, there is no day and night cycle, there is always sun. This provides 10 times the energy we can collect on land. The space-based solar power system consists mainly of three parts: the panels and the transmitter, which will be installed to a satellite orbiting the Earth, and the receiver, which is the antenna, which will be on land. The huge mirrors will concentrate the sun rays onto the panels. Then the transmitter will convert the output electricity to microwaves and transmit it down to the antenna. The antenna must be wide, a few kilometers in diameter, because of the divergence due through the large distance between the transmitter and the antenna. The satellite must be put at a geostationary orbit at a height of 36,000 kilometers, and it has to be put above the equator in order to have the same radial velocity as the Earth, and in order to be in a constant position relative to the antenna. Now we will move on to the efficiency with Mohamed El-Alfy.
To start speaking about the efficiency, we should put in consideration the process that happened before we get our solar energy from space into DC on Earth. So we have many processes. First, the solar energy is converted into DC. Then the DC is converted into radio frequency that transmitted into Earth. Then the beam collection happened on Earth. Then the radio frequency is converted again into DC, then AC to be available for daily use in our homes. So from these processes, we're just gonna focus on three of them, which have the most loss of them. So if we can achieve the best use of the three processes with the least loss, so we can achieve the highest efficiency. The three processes are DC-RF conversion and beam collection and RF-DC conversion. The first step is DC-RF conversion. The losses in this step is because the process of transmitting from direct current into radio frequency. And the problem here is crucial because we don't know what kind of radio frequency we're gonna use. So for example, we can't use any frequency from the electromagnetic spectrum. For example, if we use gamma rays or X-rays or ultraviolet, this will not be efficient at all because these kind of radio waves will not gonna go through the atmosphere because the ozone layer will suspend them from go to the atmosphere. So there is overwhelming scientific on using microwave and laser. And most studies recommended using microwave with efficiency that can reach about 70 to 80%. To generate the microwaves, scientists proposed using the vacuum tubes like magnetrons and clystrons and traveling tubes, which can reach the efficiency of conversion that can reach about 70%. Second step is beam collection. The decline of efficiency in this is because the phase, frequency, amplitude error on phased array that can cause indifference in the direction of the beam. The problem here is the divergence is increasing as we're increasing the distance. So if we have a small divergence, when it reaches the Earth, it will be a very huge divergence. So we should increase the area of the rectangle that is on Earth. There's many models that try to find a solution for this problem, but the best one and the highest efficiency was the SPS reference system. And the parameters of this system was the transmitter aperture is 1 kilometer diameter. The antenna aperture is 10 times 13 kilometers. The frequency of the antenna is 2.4 gigahertz, and we can reach efficiency approximately 89%. Here's a comparison between using frequency of 2.45 gigahertz antenna and using frequency of 5.8. We can find here that using a frequency of 2.4 gigahertz, we can reach efficiency that can reach about 90%. But here in using 5.8 gigahertz, the efficiency can maximally reach about 80%, which is less than this. And here a comparison between three of them, which is 2.45 5.8, 8.51, and if we find again that the highest efficiency is with frequency 2.45 gigahertz. The last step is RF-DC conversion, and the decline in efficiency here is because of array connection loss and the trouble of the antenna and losses in the system, which may be cables or DC AC conversion, etc. So we're using a antenna here increase the efficiency for about 80%. This is why the antenna is simply an antenna but can rectify the signal. The components of the antenna is simply dipole antenna and diode that embedded in the circuit. This dipole is the respectable of rectifying the signal. The type of the antenna along with the frequency can determine the efficiency. Also, the type of the diode embedded in the circuit can increase the efficiency. For example, we used for many years the silicon diodes, but we have introduced new diodes like the SiC and GaN, and they are expected to increase the efficiency in the next years. And here's a comparison that shows that changing the type of the antenna can change the efficiency. So the type of the antenna, which is called printed diploma, with the frequency 2.45 can achieve the highest efficiency, which is 85%. And now we have to speak about the cost with Tasnim.
For any project to be implemented, the cost is one of the main things we have to think about. As the space-based solar panel is such a huge project and it has a lot of components, its cost is like really high. And that's where most of the researchers are headed into, trying to reduce the cost of this project. First, let's define some terms before starting. A reusable launch system is a launch system which is capable of firing a vehicle into space more than once. An expendable launch system is a system in which the vehicles are launched into space only once and then discarded. Dr. Wertz, in his paper, Economic Model of Reusable versus Expandable Launch Vehicle, compared them both cost-wise. The launch cost for a reusable vehicle is $35 million, which converts into 250 million Egyptian pounds, while the launch cost for an expendable vehicle is $85 million, which converts into 608 million Egyptian pounds. The cost per kilogram ranges from $10,000 to $8,000, while the cost per kilogram for expendable is $18,000 to $11,000. Dr. Wertz also suggested that if we could reduce this $10,000 of reusable to $1,000 per kilogram, the cost of the power we will get will reduce from $1.1 per kilowatt into 80 cents per kilowatt. And that's where most of the research is trying to do now. Another comparison was done between lasers and microwaves. Laser has a startup cost from $500 million to $1 billion range, while microwave is in tens of billions in dollars. And why is that? Well, a laser satellite weighs 10 metric tons, which is a fraction of the weight of its microwave counterpart. Also, a laser satellite can be launched in a single rocket, and it will be self-assembling. So you would not need to send a robot with it to assemble it in space, which will reduce the cost and the time of production. However, laser does have some disadvantages, like it cannot pass through clouds and it will get very distorted by weather changes. Also, it's not very safe as it might cause blindness and it will literally fry anything that comes in its path. In a paper done by Dr. Gerritsen, he said that although microwave do have a high startup cost, but once one or two countries start using it, the rest of the world will know how important it is. So the demand will increase. Once the demand increases, the production increases and the cost will decrease from $200,000 to $2,000 per kilogram. What about the safety of microwaves? I'll leave you to this with Ahmed Shahen.
Moving on to another important aspect of our topic, which is safety. There are some points that must be discussed. First, and most importantly, microwaves are non-ionizing waves, which means that they cannot mess up with your genetic codes or cause any certain DNA mutations, but rather they can only cause local heating. There are 2 points that do not affect on our green world. First, the energy transmitted is 5 orders of magnitude less than that of the total solar radiation. The second point is no carbon dioxide is produced by their external, which means that space-based solar power transmission do not contribute to the global warming effect. Another thing is the energy generated at the center of the beam is approximately 30 milliwatts per centimeter squared, while the energy generated by a microwave oven in a typical kitchen is 1,000 milliwatts per centimeter squared, which is a really huge difference between both, which means that the energy generated at the center of the beam is only 3% as strong as the energy produced at the center of the by a microwave oven at the kitchen. So if we consider such radiation to be dangerous, then microwave ovens would have been the #1 criminals in our society. Taking into consideration maintenance as well, there are some points that are not only cost effective, but also are better than most of the traditional ways. Technically speaking, the use of human space missions will not be sufficient because it's rare to find an astronaut who is a technical at the same time. So the use of robots with different sizes and roles is more efficient in maintenance. Wrapping up everything with a comparison between laser and microwave, it's obvious that microwave surpasses laser with 3 points, except only the part that it's not cost effective. And certainly the output in the microwave is higher. So if we made a ratio of money per kilogram and money per gigawatts, it's obvious that laser surpasses microwave in the former and microwave surpasses laser in the latter. So it's expected that so many researches and studies will be considered for this action. Maybe by using solar panels with lighter materials, making cheap space missions, or using other transmission generators. Thank you.